everyone. It's such a pleasure that Blue Talks is continuing. So this is the season number 2. And it's a little bit different than the previous Blue Talks. We had previously 8 of them. All of them are available on YouTube. You can go and see them. Now we are changing it a little bit and making it a little bit more fun, I hope. So we are having one topic. We will have 4 talks from 4 different disciplines, 4 different universities. As you know, we are a CU alliance. We have 9 universities now in our alliance, and I hope that we will work more on this Blue Talks format and see how we can develop it further. So any kind of comments or suggestions are always welcome. And with this, I give the hosting of this Blue Talks to Kiel. And please, Nicole, the floor is yours. The Blue Talks is yours.
Okay, thank you, Nicola. And on behalf of our university, despite she is speaker as well today, but her role as a vice president and also being a member of the governing board of the CEU Alliance, I would like to hand over to Nele Matsluk.
Thank you so much, Nicole, and thank you, Nicola, for putting this up. Yes, I'm here again as often with 2 hats in a double role. One as a speaker from my field of the law of the sea, and one at this time as welcoming you to this new format of Blue Talks on behalf of the Presidential Board of Kiel University. We're very much looking forward to closing our ties and to do this via the exchange on the research in these little groups. And I think with maritime transportation, we will have, as you already see from the titles, a very diverse field. And I'm sure there will be much to talk about, to discuss, and also continuation. So I'm very much looking forward, and thank you all for joining.
Okay, thank you, Nele. So we start with the first talk from University of Gdansk. I'm glad to introduce you to Magdalena Jaśdżewska-Guta. She is assistant professor for sustainable market processes at the Faculty of Economics at the University of Gdansk. And her talk today will be on supply chain security, the maritime perspective. Magdalena, welcome, and the floor is yours.
Good afternoon. It's a pleasure to be here. Thank you for the invitation. I'm a little bit excited to deliver this talk today. At the beginning, I would like to apologize for my strange voice. It's just the result of 3 days of lectures, and I'm doing all my best. This is not how I sound usually. I prepared a short presentation, so I'll try to put this here. Okay. I hope you can see the slides, the first slide. Okay, thank you. This presentation is about supply chain security with the focus on maritime perspective. However, we cannot consider the maritime perspective without looking at the entire supply chain, because usually a lot of transport goes in containers. Without the cargo is closed in the container. In the intermodal transportation, it is more difficult to check what is inside. So containers are seen as one of the major threats to the supply chains, to the supply chain security and to the transportation network. I would like to try to answer a few questions in my presentation, because I would like to look at the supply chain security issue from the perspective of the weakest link public good and oh, sorry, I'm a little bit stressed, and interdependent security. And the questions are, who is the weakest link in the entire supply chain? Is maritime security the same as supply chain security? And who should be responsible for the maritime security? And is there any optimal level of security that should be achieved? I think we are representing different fields, so I decided to share the definition of supply chain security It can be seen as a state of being free from danger or threat. So actually, we try to do everything to protect the supply chain and to avoid some disruptions. Supply chain security can be also defined as actions of supply chain participants and different actors in the supply chain, like international organizations, public institutions, that are undertaken to protect the supply chain and its environment against criminal activity. And these criminal activities can include different threats, different crimes such as piracy, thefts, counterfeiting, espionage, illegal migration and trafficking, smuggling, especially the case of weapons of mass destruction was mentioned in many documents on supply chain security. And of course, we have terrorism, which is a little bit different from the criminal activity, typical criminal activity. And we should say that security is something different than safety, because safety is about health and about the protection from damage, unintended damage, and security is about intended unlawful acts. And there are two motives for such activity. If this is the intended or the primary target is the government or national or social stability, usually the supply chains and including maritime transportation are the secondary target, because the main issue here is to do some harm to social, to society or to governments. And for the other types of crimes, we have financial motives. So then the supply chain is the primary target. And if someone is hurt, this is not usually the primary target, but this is just the external effect of this attack on the supply chain. And in every supply chain, we have, of course, different companies that are the direct links in the supply chain, such as raw material suppliers, manufacturers, wholesalers, and all the service, all the services like the companies offering the services like shipping companies, carriers, logistics service providers, and of course the environment. And when it comes to maritime supply chain or the supply chain with maritime component, we should talk about the seaports, which are the gateways and all the connections to the hinterland and foreland. And of course, we consider the country of origin, country of destination, all different actors. So that is why we can talk about interdependent security. Every disruption that happens in one point of this supply chain, that is the disruption to one of the links in the supply chain, can be easily transferred, is easily transferred to other links in the supply chain. That is why we should consider not only the maritime security on its own, but we should consider the security of entire supply chain. And I think everyone knows this famous statement was saying that supply chain is only as strong as its weakest link. And I would like to say a few words about the theory that is a little bit forgotten and maybe not mentioned so often. Actually, supply chain security can be seen as a public good because everyone can use this good without diminishing others' possibilities of using this good. So everyone gets something from the security. However, this is not a standard public good because in the standard summation formula, the total amount of public good that is produced is a sum of the amount of public good produced by different members of the community. And in the weakest link case, the total amount of public good produced is just the minimum of the amount produced by each actor in the community or member of the community. That is why if we have too much expenses in the security area, it will be not efficient because the security of the entire supply chain will be dependent on the weakest link. And I've prepared such a graph to present how the situation may look. So on the horizontal axis, we have the total cost. So these are the total expenditures on security. And on the vertical axis, we have level of security. So how much of this good, which is security, is produced. And the first security measures we introduce usually don't cost so much, but they can bring great results in enhancing security. And every next unit of money we spend produces lower effect on the entire security. So to keep the security at optimal level, we should produce. Oh, maybe I will try to show the. I hope you can see the red dot. So if everyone produces the same amount of the security, then everyone is protected, and entire link, entire supply chain and its environment is protected in the same way, at the same level. But if any company doesn't keep its promise or spends less or doesn't keep the level of security required by others, it becomes the weakest link. And actually, this is the entity or the link that can be easily attacked by criminals. And the blue area here represents the amount of security that is lost due to the weakest link occurrence. And it shows us the inefficiency of security spending if we allow for the weakest link to be present in the supply chain. So who can be called the weakest link? This might be the smallest contributor, or an agent with the lowest benefit cost ratio. This is the case for the criminals, who usually look for the situations which bring them the lowest effort with the maximum results. This can be the link with the highest probability of disruption, or the least protected player in the entire network. This weakest link can be also defined as a minimal defense level or smallest deployed force. So there is no single definition of the weakest link, especially if we consider the fact that criminals usually search for the weakest points in the entire network, and they tend to change their strategies if some links are protected better than before. And why we should say about weakest link also in the context of the intentions of criminals or terrorists. I have two examples of two ferries connecting two different parts of land. The first one on the left is the ferry connecting Manhattan in New York with the Liberty Island. And to get on this ferry, you need to go through the security check, like the airport style security. And it is very difficult to bring any sharp objects and so on. And on your right, you have the ferry connecting Malta Island and Gozo Island. And you just enter this ferry without any security check. So why is that? Because the ferry to the Liberty Island, where the Statue of Liberty is located, is going to a location of a strategic and symbolic meaning. That is why it can be considered as the weakest link, not because of the level of protection, but because of the attractiveness to possible attackers. And as for the weakest link, I said about the expenditures that companies are willing to incur or are not incurring for security reasons. And this is not the newest data, but I think it's quite interesting. It is based on a survey among exporters and importers from Poland and Germany. And they were asked how much they would like to spend for security, how much additional cost they would spend for security. And most of the companies said they would like to spend nothing or minimum amount. So usually, especially the smaller companies and the companies involved in international trade are the weakest links because they just don't see the problem. They don't want to invest in security. And actually, the maritime transport is one of the modes of transport in which the companies are willing to pay the most. So I think it's quite interesting. And usually the bigger companies, the bigger cargo owners tend to spend more on security measures. And they are able to obtain different certifications, like, for example, AEO, Authorized Economic Operator in European Union. And together with my colleague, we launched a survey among AEO certified companies. And it occurred that the service providers, including the carriers, also maritime carriers, road carriers, but also the logistics service providers and freight forwarders, are obtaining this AEO certification to gain competitive advantage. And only the cargo owners, who are the exporters and importers, want to achieve this certification to improve their internal processes. But we have to remember these are the big companies. Usually the big companies get this certification. And as for the big companies and maritime sector, I recently looked into the sustainability reports of the major container shipping companies. And it shows that every company is including the security issues in their sustainability reports. I think it's quite interesting because it shows that the security is also the case for sustainability for externalities of the supply chain. Usually it concerns the cybersecurity and protection from piracy threat, but also it is about the security of personnel. And I think it's, I have two last slides to show you. These are the opinions of the exporters and importers from Poland and Germany, who should be responsible for enhancing security. And most of the companies from my research answered that this should be the common, the collaboration between the companies and the government. So this is about the CityPath program in the United States or AEO program in European Union. Some say that these should be companies together with international organizations, and no one says that they should be companies on their own. So about the security measures in supply chain and public transport. So what can be done? So we can enhance the public-private collaboration, but also the industry collaboration where the bigger companies encourage smaller companies or even subsidize the smaller companies to introduce new security measures. So we can subsidize also the weakest links in the international context. This will be the poorer countries, for example, or we can privatize the security. This is what is done by the British government. I think we will have the presentation on migration later. So these are the fines imposed on carriers who allow the clandestine entrants to be hidden in their trucks. We can also introduce some kind of mechanism that user pays. This is what the shipping companies do when they impose special surcharges connected to security issues. And we should also reduce the asymmetry of information. And just to conclude, to answer the questions. So who is the weakest link? There is no single answer because of the motivation of criminals and terrorists, and the different levels of protection of supply chains. Is maritime security the same as supply chain security? No, but in both we have the same actors, we have the same means of transport, and they are interconnected. Who should be responsible for maritime security? The answer should be everyone, because if we have the weakest link, this will be the most difficult situation. What is the optimal level of security? It depends on the actors, on the criminals, and so on. And there are also the externalities, and this is the case of sustainability, which I think is the future research area not explored yet. Okay, I try to thank you for your attention. I tried to be as quick as possible with this presentation. I hope I didn't extend the time too much. Thank you.
Thank you, Magdalena. Very, very interesting. So it's the opportunity for the audience to ask questions through the questions and answers button on the top row of your screen. You are free to ask anything, and Magdalena will try to answer. Maybe to start the discussion, I have one question. You showed on your slides basically the cost relation of efforts you do to increase security. Yeah, and then I was wondering whether a potential aggressor, if this applies to a potential aggressor as well, or so the higher the security standard, the more effort the potential aggressor has to make, really, or is it also maybe not a direct relation, because it could, could be other reasons to be successful as an aggressor?
Actually, there is quite to paraphrase what Albert Einstein said, nature can be subtle but is not malicious, and so we can find some solutions to the problems, to the natural threats, natural hazards, and we can say, okay, we are protected against them. But when it comes to the criminal activity, usually they are always looking for some weakest links. They will try to make their strategy even better, and all the terrorist attacks and all the criminals always show that they are able to improve their activities. So I think it's just the game between the supply chain participants and the criminals.
Okay, are there other questions from the panel? I don't see any from the audience. Nicola?
Maybe I can start, because the idea behind the Blue Talks is also to inspire for new projects and new research collaboration. So where would you see the most, what would be the most interesting way for a new research collaboration or new fields of research in this topic?
I think the first one would be the sustainability issue, the externalities, and how the companies deal with this problem. I think this is quite an interesting issue, because more and more companies in the logistics sector include the security issues in their sustainability reports, or so this is like the first area. And the second area is to try to investigate the single supply chains and check what are the weakest links, because this is something that has not been done on a larger scale, I would say. And the next area is also the security of containerized transport, because there are not so many publications on that. So intermodal transportation.
I'm writing everything down. Thank you.
Okay. No questions from the panel. Also, I don't see any questions from the audience. So there's always time to ask your question later on. So we continue then with the next talk by Luka Vukic. He's also assistant professor and head of the Maritime Management Studies at the Faculty of Maritime Studies at UNIS, University of Split. And Luka, your talk is on maritime energy transition, and the floor is yours.
Thank you. I will share my screen. Can you see the slides?
Yes.
Okay, perfect. So as Nicole introduced me, I'm Luka Vukic. I'm assistant professor of Faculty of Maritime Studies in Split, Croatia. Today I'll be presenting this very interesting, very actual, this presentation, which is in trend, titled Maritime Energy Transition. So we can see the content of today's presentation. I will briefly set down the fundamentals of and importance of maritime energy transition for the whole industry, not just isolated the maritime sector. I broke down this presentation on 3 pillars. So the first one are the drivers and regulations for decarbonization. The second one is the ship technologies and fuels. And the third one will be alternative fuel production and the requirement to invest in the new infrastructure. So in the introduction part, I was aiming to explain why energy transition is a very important topic, because it deals with reducing the GHG footprint. So the shifting to carbon neutral fuels is something which is in trend, something which IMO adopted, and something that also European Union is expecting to achieve some plans until 2050. We will see in today's slides. So this shifting could.
Sorry to interrupt. Could you change to presentation mode, please? This would.
Okay, like this.
Thank you. Perfect. Thank you. Sorry for the interruption.
Sorry, no problem. So this shifting to carbon neutral fuels will surely impact on the costs, the asset value, and the capacity. So you can see in the introduction part, the main challenges would be the fuel availability and infrastructure. So the new infrastructure in the ports, who are the main nodes in the supply chain, should be and would be needed to adjust. So the decarbonization is the objective of maritime energy transition in order to reduce the emissions to air. As already indicated, this shift to carbon neutral fuels, you can see here the list of the potential fuels who should be also standardized, like ammonia, diesel, electricity, hydrogen, methanol, and methane. Also, why this technological development and transition is specific, because in the previous transitions we had the shifting from wind to coal and steam and then to oil. This energy source was standardized, and here in this very complex, let's say, environment, the regulatory body didn't standardize the fuels and the fuel sources. So there is a great amount of fuel flexibility. This will also impact the whole industry. Let's get down to the first pillar of the drivers and regulations for decarbonization. You can see on this slide that main drivers are coming from the regulatory body, like from the IMO, so International Maritime Organization, which adopted the carbon intensity measures, so the requirements like a carbon intensity index, energy efficiency existing index, and ship energy efficiency management plan. So these measures should be implemented in the optimization phase of the existing and the new build ships. Also, the EU implemented this Fit for 55 package. It means reducing the GHG gases 55% by 2030. They introduce also the emission trading system, so the trading of the emissions between the companies in the maritime industry. Also, one of the objectives is to establish green corridors, so to optimize the whole supply chain. And IMO is in 2023 is going to revise its GHG strategy, which will be based on the adjusting the technical requirements and market-based measures. The IMO set down the guidelines for calculating life cycle GHG emissions, and as I already told you, the fuel flexibility is driving complexity, and it will be key strategic elements for the new buildings. Here on this slide, you can see all of the initiatives, incentivizes from European Union and the International Maritime Organization. Here on the bottom part, under the keel, you will see the measures, technical measures like energy efficiency design index, for which aims to optimize the hull improvements for the new buildings, and energy efficiency existing ship index, which deals with the existing fleet. So these are the technical measures. The managerial measures are implemented in the ship energy efficiency management plan, which aims to continuously improve the optimization of the ship processes. And the operational measure is carbon intensity indicator. So it deals with, it addresses actual carbon intensity from the ships. In the upper part, you will see some financial incentivizes to reduce GHG gases. So these are emission trading system and global GHG fuel standards. You will see here on the next slide. So the market-based measures, which aims to set the price on CO2 or GHG, either well to wake or tank to wake. Well to wake means that the whole emissions, the whole life cycle of the emissions should be monetized. But on the other hand, tank to wake, it means that only the emissions from ships, from maritime industry, from bunkering, let's say, spaces on the ship, and the emissions should be monetized. Here you can see the 4 variants of market-based measures. So the first is a Levi system based on the absolute well to wake, so the whole life cycle calculation of GHG emissions. The second one is Levi system based on carbon intensity performance, where the ships which perform better will be benefited in the context of contribution per ton of CO2, and the other ships which are performing below the benchmark would be penalized. Above the benchmark would be penalized. Sorry. Or the third one is the Levy system based on the absolute tank to wake CO2 emissions. So it deals with the emissions solely from the ships, combustion system, and emissions to air. And the fourth one, it deals with the emissions cap and trade system, similar to the emission trading system, which is incentivized in initiative from the European Union. So the basic intention is decarbonization, but let's say the intention is not to shift the emissions to other sectors. It means that the elimination of and reduce the emissions should be achieved. It would all these incentivizes and Levi system and market-based measures, these financial incentivizes to reduce GHG emissions would coincide with the increase in transport costs. Here on the next slide, you can see the timeline of the regulatory processes and decisions from IMO and the European Union. Let's deal with firstly with the adopted regulations. So in 2022, there is adoption of energy efficiency design index, which would be adjusted in the third phase. In 2023, adoption of energy efficiency existing design index, which deal with the actual fleet, so not the new buildings, and enhanced ship energy efficiency management plan and carbon intensity indicator. In 2025, the energy efficiency design index will be applied to all ships. The possible regulations which are projected will be adopted in 2024. It deals with the revised data collection system and emission trading system for shipping, fuel, maritime GHG fuel standards. It deals with financial incentivizes to reduce GHG gases, and in 2026, IMO carbon price, fuel standards, and black carbon, very volatile organic compounds. In the process, we have life cycle assessment in 2023, so the guidelines for fuels and a revision of GHG strategy, which is very important for the industry. The comprehensive impact assessment in 2024 and a CI and EEXI revision in 2025. The second pillar, the ship's technologies and fuels, they broke down it into three parts. So the reduction of GHG gases will be based on the three components. The introduction of new fuels. So here on the labeled in green, you will see the efficiency indicator. So the introduction of new fuels like hydrogen, ammonia, methanol, wind power, biofuels, LNG, LPG, which are transitional fuels, should and would have to be and can be expressed in efficiency performance from 0 to 100%. Also, the nuclear power is very interesting, but the nuclear power is very complex, but the public statement should be also be provided. So it should be also communicated with all the stakeholders and with the public because of the negative aspects of nuclear power in the combustion of ships and other technologies. The second pillar of new fuels is carbon capture and storage. This is, let's say, technology which is maturated for land-based industries, and it can have this efficiency indicator up to 30%. The second part is energy efficiency. It deals with the optimization of ship's hull, improvement of hydrodynamics like hull coating, hull form optimization, air lubrication and cleaning, and also introduction of new technologies. This is innovative, let's say, technology in order to enhance energy efficiency, like sails, waves, and solar. Yesterday, I think that one ship based on the sail technology was set in exploitation in a bulk carrier transporting coal, having this kind of technology in order to reduce environmental footprint was introduced and adopted in the operation. So these are all new technologies which should aim to increase energy efficiency. The second part is machinery. So increase the machinery efficiency, waste heat recovery, engine derating, and battery hybridization, fuel cells. This is very also interesting, and it should result with a 5 to 20% of efficiency improvement. The third part is logistics. So you can see here that some incentivizes are speed reduction, vessel utilization, vessel size, alternative routes. So increase of the efficiency and productivity of the whole supply chain and logistical part. But with implementing the digital technology could also reduce the environmental footprint. The ship technologies and fuels here, if you can see the key barriers of the uptake of low or zero carbon fuels, this is increased capital investment. Capital investment, it deals with the problems and challenges in investments in ships, investment in technology, investments in extracting of the fuel and production of the fuel. The limited fuel availability, this is very also important. This is also one of the obstacles which should be also eliminated. A lack of global bunkering infrastructure, it deals with also capital investments in the port infrastructure. You will see in the further slides where are those main key bunkering points and how all the ports which will be the key subjects in taking and drawing this this energetic transition in success. Also, high fuel prices. We are all aware of this geostrategic instability, which is producing these effects, and the extraction and producing of these alternative fuels will be also dealing with the higher prices, and the additional demand for onboarding storage space. So all the supply chain, all the components of the supply chain should adjust. Also, the ship technology should be adjusted in order to carry these carbon neutral fuels, in order to also to combust and in order to produce energy and to drive the ships. On the right side, you will see the number of ships in operation. So 98.8% are based on the conventional fuels. So just 1.2% are based on alternative fuels. The dominating factor of LNG is visible. On the right side, ships on order, so 78.9% are conventional fuels, and just 21% is based on the alternative fuels technology implementation. And the bottom breakdown of the number of ships in percentage of gross tonnage is indicated. So you can see here that in operation there are 923 LNG ships, 396 battery and hybrid, 19 LPG, and 11 methanol ships. So these are all drivers which should be considered when implementing and when overtaking this energetic transition. Here on the next slide, you will see the ship technologies and fuels based on the maturity level. So these are set of technical and operative measures in order to adjust onboard fuel technology. Here, the technological part is based on the combustion, so 2-stroke engines, 4-stroke engines, boiler, fuel cells, and the regulative part, a regulative maturity of adoption and of individual fuels. So you can see here the breakdown on the 4 fuels which are indicated as the fuels of the future, and which should be and could be delivered in mass production. So methanol is the status of technological aspect and regulatory aspect of methanol is higher than for ammonia, hydrogen and carbon capture systems. Ammonia has the challenges of combustion properties, nitrous oxides and ammonia slip. On the other hand, hydrogen has a challenge in low energy density and corresponding space on board, and carbon capture system and storage is mature just for land-based industry. So also there are some chemical and physical characteristics which should be also taken into or considered or taken into account, like toxicity of methanol and ammonia and flammability of hydrogen. So in this moment, methanol or the ships having technology to combust methanol for 2-stroke engines. These 2-stroke engines are mainly implemented in the ships, in bigger ships which are carrying cargo, is developed. So this technology and the regulative part is developed, and like you, I think, or if you are not aware, then I don't know, Maersk, like one of the largest shipping companies, ordered some 20 container ships with methanol technology. On the other hand, also the digital technology with decarbonization, we can label them as transformative forces. So these are the main trends in maritime industry. The digital technologies are listed here on the left side, like blockchain, machine learning, artificial intelligence, IoT, connectivity, computer-based simulations. They can also make and help to overcome and increase the efficiency and the energy efficiency of ship technologies. We can also break down the impact of digitalization on the 3 parts. The first one is in design phase. So design phase is based on the model simulations and optimization, like hull design and lower hydraulical resistance. The second one is the ship in operations, like the digital technology can help in monitoring, routing, planning, diagnosis, also simulation-based training for the crew, and just-in-time concept. And the main objective is to create digital twin, who should learn from itself. And by this learning, machine and artificial intelligence to adopt and to increase the efficiency. The third part is based on the fleet optimization. Also, some of the possibilities are simulating and operation of optimization, sorry, of the fleet size, the speed, predictive analysis, and so on. So digital technology can severely impact in the positive aspect to the energetic transition of the maritime industry.
Luca, may I ask you to pay attention to the time, please?
Sorry,
Yeah.
sorry. I have 2 slides left. So this slide deals with the infrastructural challenges. You can see on the slide the main bunkering hubs. So the ports should and would carry the key role in this transition, and the fuel market will be diverse. There will be multiple energy sources, interconnected regional energy markets, and here the emphasis is on the fuel flexibility. To conclude, here you have the future carbon neutral energy supply chain. The conventional supply chain is based on the source, or is based on the fuel extraction, also production of the fuel, distribution, and the combustion. Also, here, if we talk about the sources of energy, we can break down also this part on the 3 elements. Sustainable biomass can be very important in order to generate biofuels by forestry residuals, agricultural waste, electrofuels with the help of renewable electricity like hydrogen, electrolysis, and fuel cells, and fossil energy in order to generate blue fuels like carbon capture of the CO2. In the distributional part, we will have challenges in the productional part. Sorry, we will have challenges of the adoption and using the existing infrastructure. In the distributional part, we will have challenges in storage, bunkering, and availability of infrastructure and technology. To conclude, the preparation for decarbonization is in the progress. The focus is on the complete supply chain emissions. The increase of alternative fuels on ships is in progress. Also, with the onboard technology adjustments, availability of alternative fuels in connected regions will be the future market of alternative fuels, and digitalization can enhance the energy efficiency and information sharing. Thank you for your attention, and sorry for the time consumption.
Thank you, Luca. Thank you very much. I'm sure there are questions, although I don't see any in the chat now. Nele.
Yes, thank you. Thank you, Luca, for your presentation. And I have a couple of questions. Maybe I will leave it with 2 questions. One of my questions would be, who has to move first when we talk about new fuels and the energy transition? So it's my impression that the technologies are there, but then ship owners say, well, as long as the ports don't have the infrastructure, we're not getting. So who has to move first to really make the transition? Because the ship owners will just look at their competitors, and they don't want to lose money. They don't want to invest in a certain technology, and in 2 years there's something that is cheaper, because you've mentioned costs that are really the main driver. And the second question is concerning the European emission trading initiative for shipping. Do you think that this initiative in Europe would be would put enough pressure on the International Maritime Organization to finally decide on market-based mechanisms, and how could they look like? Thank you.
Thank you for your questions. Very interesting. So I think that the first step should be from regulatory body, because as I already mentioned, let's say the mayors, like the industry leader, just ordered these new methanol ships, and all the other, let's say, competitors are leading. So I don't know. There is one company nominated as Express Feeder Lines, which are dealing with the feeders, which after the order of the mayors order another portfolio of feeder ships based on methanol. I think it will be very complex, because as I mentioned, this technological development is driving complexity, because there is no standardized fuel here or in this moment, and the development phase, because the other technologies excluding methanol are in the development phase. As you saw from the timeline, the ammonia has their own challenges. Hydrogen has their own challenges, and carbon capture has their own challenges. So these challenges has to firstly be overcome in order to think about the implementation in the mass production of this and mass utilization of these fuels. The second question, the European trading system. There is one incentive from European Union. It deals with internalization of this external cost. The trading system, my opinion, that if we look upon the basics of the reducing the GHG footprint, with the market-based measures, we are just monetizing these emissions. We are not eliminating them. We are just restricting them. But to eliminate completely the emissions, I think that this market-based measure should be implemented by this tool. The ship owners should tend to be more energy efficient. But this emission trading system would just allow the big players to emit more, because they have more let's say money to compensate for this trading of the emissions. So I think it is very complex. I don't want to speculate, but it will be very interesting what will be done in the few years, in the further periods. Thank you.
Thank you. And then there's a question or comment by David.
Yes. Hello, Luca. I really liked your talk. You gave a really broad view of the topic that is actually very interesting to me. So the feeling I get is that most of the measures that you were mentioning involve very large investments from the industry sector. I mean, to transition towards other sources of energy. By way of contrast, actually the topic that I will be talking about is comparatively very cheap. I would call it a low-hanging fruit, which is just using a wiser choice of routes and using sea currents and using winds. So all this field that's called weather routing. Mm-hmm. I didn't see that explicitly named in your slide, so I'm kind of curious to see whether this is more or less taken for granted that everybody's using it, or is it considered to be not important? Because I mean, you can achieve reductions of around 4 or 5% easily with almost no investment. So I was curious to see your view on this.
Very interesting. I don't know, in the logistical part, did the weathering optimization was integrated, but I'm not taking this for granted. I think that this is very important. But if we can't predict the future, but we can back upon the historical, let's say, implications. The transition from sails to coal and to steam lasted for 60 years. So this is a long time process. And I think that all these components from logistical part, from availability of alternative fuels, and the possibility to optimize ship performance should be integrally taken into consideration, and all the possibilities in order to increase this energy efficiency should be applied. For sure, the weathering, routing, and optimization of the planning, monitoring, the diagnosis of the ships, and the simulation-based optimization of the hull should be firstly, let's say, laid upon. That's why the IMO adopted these initiatives, this CII energy efficiency existing ship index and energy efficient design index. So this technical, operational, and management, let's say, measures in order to enhance the existing technology. But if we are talking about the longer scale and the mass production, let's say, and utilization of methanol, the ammonia, and I don't know, hydrogen, the technology imports, like the main bunkering hubs, it should be, it will surely imply the increase in costs, the asset value, and the capacities. Also, as I already mentioned, onboard technology should be and will be required to adopt. I don't know if I answered you correct, but this part, yeah, I know this part is very important, and this should be the first step. But the energy transition is a global problem, and it's a long time process. So we'll see how the industry would deal with these challenges in the future.
Thank you.
Okay, there's a whole bunch of questions from the audience. Maybe I try to summarize it. It's basically a question on who pays the increased costs of for the transportation. So who pays the bill? And the question is whether
final consumers.
The consumers.
Yeah.
Yeah, but I'd like to add to this, like my colleague Christian Wagner IFC organized an event here together with the University of Gdansk, and we visited the harbor authority, who had some real, well, big investments in onshore power facilities. So it was publicly funded. Public money, otherwise it wouldn't probably have come to reality.
Yeah.
So it was an investment by the Harbor Authority and paid by public money, but it enables now cruise ferries to get electricity rather than have their engines running in the harbor. So it's a public investment, and it probably doesn't really increase the costs of the ship owner. I don't know for sure. I'm not an economist. I didn't see the bill, but
yeah. It's a cold ironing technology which was implemented in some ports. It enables to shut down the main engines and to plug the auxiliary engines on the electricity on the grid from the shore. This technology increases energy efficiency. Like the other, because let's say we are dealing, if we are talking about cold ironing technology, we are dealing with the emissions in ports. But what about the emissions which are emitted, which are produced in the rural, on the open sea? So if we are talking about the whole industry, that's why the topic of this presentation is energy transition of the maritime sector. But I indicated in the introduction part that it will apply to the whole system, the whole traffic industry. So, and on the global scale, the implications would be generated. So the cold ironing technology is very important. It increases this indicator to reduce the GHG gases, but in ports. This is just one part of the supply chain. So on the global scale, the search and the development of the alternative technology, the alternative fuels and the technologies would be also required. And as the bills will be, let's say, will be transposed to ship owners, but the ship owners would increase the price of their services, and the end users will surely pay for these bills, as we also hear now in the 2022. As for the congestion, the impact of COVID-19, we also that the price of container transport rapidly increased. I don't know, if you wanted to shift one container from China to Rotterdam in 2017, it would cost you 75, 70, $150. In 2021, it's $17,000. It was the price of this service. So we can see here that the end users or the shippers are paying these bills.
Okay, thank you, Lucas. So we have a short intersession and comfort break, and we reconvene. It's now 5 minutes past, so 10 minutes past. So we have a short break.
When are we returning? Would you?
10 past.
10 past.
So everyone back, I hope. So warming up a little. Our next talk is by a speaker from the University of Cadiz. It's David Gomez Ulate. I don't know, I'm sorry if I don't pronounce it properly. And he's professor of applied mathematics and head of department at IE University. What is?
IE is a private university in Madrid, so I just moved. Yeah.
Oh, okay. So you're not at Cadiz, but you have been nominated by Cadiz.
That's true.
Yeah, okay.
So they probably miss you already.
Oh, I'm sure, I'm sure.
I certainly miss them. I certainly miss them.
Yeah, we touched upon on your topic already. You will be talking about smart shipping, weather routing, and performance monitoring for maritime transport. So, David, the floor is yours.
Thank you very much, Nicole. Let me try to share my screen. Ooh, is this working? Let me see. Oh no, so now I need to change my, all right. So give me a sec, because this is Zoom. Okay. Okay, I need to.
It's gone now.
We lost him. What to do now? He will probably quickly reconnect, or maybe we could proceed, Nicole, and see when he connects to.
If he doesn't come back, I could give my presentation first, but his would be much better fitting now.
Yeah.
So maybe we should give him.
Maybe we'll just wait a couple of minutes, I think.
So maybe I could ask something for Luca or everyone. David is already here.
Yeah.
Perfect.
Okay, I hope you didn't miss me too much.
Oh, sure, we did.
I'm sorry about that. But I didn't normally use Zoom, so I couldn't share my screen. So now probably you should be seeing my screen.
Yeah, and your email account, which you wouldn't probably want to share with us.
Okay. So let me go straight to my slides. All right. Okay. So, well, thanks a lot in the first place for the kind invitation. This work originated in Cadiz, where I've been working for about the last 4 or 5 years, but I just very recently moved back to Madrid. So that's my new place where I work. And it's both research that stems from university, as it is a venture. So we have also a small spin-off company that's trying to turn all these ideas into a product that actually will have an impact on the maritime industry. Okay, so the project is called Smart Shipping, Safer, Cleaner, and More Efficient Maritime Transport. So let's see what this is. And to motivate it, let me start with an example that probably everybody will be able to understand and to relate to, and that's Google Maps. Okay, so when we drive, my university has a campus in Segovia, which is a small town north of Madrid. And when I have to lecture there, I just sit on the car, press Google Maps, say I want to go there. And there's 2 routes that I can take. One of them that happens to be the shortest one, which is 80 kilometers, is what you would call a scenic route. So it goes up a mountain pass, goes down on the other side, and it takes about 1 hour and 12 minutes from Pozuelo de Alarcón to Segovia. Okay. Now, most people wouldn't take this route, especially if they're on a rush. They would take this other route, which takes only 55 minutes because it goes through a highway, through a big tunnel underneath the mountain. You need to pay a little bit, but you see, you drive longer, but it's shorter in time. And actually, I don't know if you're aware of this, but since a month ago, Google Maps also has a calculation on how much energy you're saving. So Google Maps is telling us by taking this route, even though we're driving a longer distance, we're spending 5% less fuel and taking less time. Okay, so I mean, if we were all drivers, you would definitely take this route, unless you are in a more romantic mood and you want to see the mountains, right? Everybody understands this. All right, but what about when you are traveling on the sea, when you're seafaring? Well, this is how the sea looks. Now here you can go everywhere. There are no roads. Aren't there? We should see something like this when we look at the sea. There are also roads in the sea. There are highways, there are secondary routes. And the reason why there's also roads and preferred routes on the sea is precisely because we have different currents, different waves, and different wind along all the different routes. So this is the equivalent to going up a mountain pass. If you cross a region where there's very high waves, your ship is going to have a higher resistance and it's going to spend more fuel. So you better know where they are. Now, continuing with this analogy, the problem is that, of course, they're harder to see. So you don't see the routes, you don't see the highways on the sea, but they are there, okay? And not only you don't see them, but they're constantly changing, which makes the whole thing a little bit more challenging, okay? So what would be the optimal route if you live today might not be the route that you would like to take if you live, say, a week from now. This is constantly changing, okay? But fortunately, we have access to all this data because the European provider, Copernicus, and the American providers, they give us forecasts and they give us very fine-grained information, which is, of course, obtained from models, and they're only accurate to a certain extent. But we have a very good understanding on what the conditions are going to be during a certain trip. Okay, so what is the motivation for a project? It's a threefold motivation. Two of them go always hand in hand. In this case, they're completely aligned, which is if you save fuel, you're not only helping the economy, but you're also helping the environment. So in this case, there is no controversy. I mean, you burn less fuel, and this is gonna help you on both things. Now, you might know that fuel is now more than 60% of the total cost of operations in the maritime industry. Just the cost of fuel, okay? Back in the day, in the 1950s, most of the costs were involved into loading and unloading the ship. But after the container ship was invented, all this process is super efficient, and actually fuel is what drives the price and what dominates, okay? Now, the environment, thanks to Professor Vukic's talk just a while ago, you are very well aware that the IMO wants to reduce its emissions by 40% with respect to the value in 2008 in 2030. So this is just 8 years from now. So everybody's crazy about trying to implement all sorts of measures to decarbonize the sector, okay? And last but not least, there's also the security. Most of the accidents that happen in seafaring are due to sailing under adverse weather conditions, as you can imagine. And this is dangerous both for the crew and for the cargo, okay? So this project has an impact in at least 2 of the SDGs that I'm not going to get into. Everybody speaks about carbon dioxide and greenhouse gas emissions, but maritime transport is also very heavy on sulfur dioxide emissions, which contribute to the acidification of the water cycle, which are also very important. Okay, but anyway, I will not extend myself on this. You're probably more expert than I am. Let me talk you a little bit about the economical issues. This is just some rough figures for you to get an idea of the order of magnitude that we're talking about. Now, a large container ship can spend of the order of 150 metric tons of fuel per day. Okay. Now, the price of a ton, when I wrote these slides, was around $900. This is the low sulfur fuel. A trip from Spain to China, which happens often, takes on the average 36 days. So if you multiply it through these 3 numbers, it will give you a rough figure of around $5 million in the cost of fuel just to move a container ship from Europe to China. Okay, $5 million. That's just the cost of the fuel. Now, if we're able to save 1.5% by using a wise choice of routes, this means that with just one trip, we're helping the company save around $70,000. Okay, so you might as well charge them $20,000 for a year license, and this means that within a couple of weeks, the company will have already profited from the investment that they did on the license. Okay, so we're trying to turn this into a product, and of course, we're not the only ones. There's two companies that I'm mentioning there. One is Norwegian, the other one is Greek. Probably you know others, and everybody's now is trying to get into this market because we have a lot of data. We have all the elements and all the technology out there to actually help the shipping industry in finding better routes. And as I mentioned before, this really is a low-hanging fruit. I mean, it's something that you can do at almost no cost. Okay, and you can save a lot of oil. So I'm not an expert, but in my eyes, this is almost stupid not to do this. Okay, so this is what we try to do. We get a lot of data from currents, winds, from the AIA's trajectories. Consumption data are hard to get by, but we're trying to cut some deals with shipping companies to have the consumption data. Once we have the data, we need to do modeling of what the consumption of the ships are going to be. And when we have good consumption models and the data, the next step we need to do, and this is where my expertise lies, is on the mathematical problem, which is optimizing the routes. Okay, so this is in a nutshell what we try to do. Now, consumption models, these really lie on the field of naval engineering. I'm not an expert on these things. I'm actually, as we speak, I'm now in a Congress of Naval Engineering in Palma de Mallorca, trying to learn about all these things. But all in all, this is a field that has been very, very thoroughly investigated. And naval engineers, they have good models to calculate what are the resistance in calm water, added resistance due to waves, to wind. This is all hydrodynamics, right? And sea currents, you only add the velocities if you remember your vector calculus, and that's also very easy to take into account. Okay. In the future, we'd like to go beyond that and actually install sensors on the vessels and have the information from these sensors to develop data-driven models through artificial intelligence. Okay, this is actually the stuff that I'm more comfortable with rather than naval engineering. And finally, we can also try to incorporate all these safety and comfort measures from the IMO to ensure that the motion of the ship doesn't go beyond certain angles of roll and pitch that would endanger both the crew and the cargo. Okay, so once you have the data and once you have your models, which are, say, a bunch of equations or numbers, the next thing you need to do is to optimize the route. And optimize you can do according to several different criteria. And this, of course, depends on the customer. So one vision would be, I want to make sure that I don't get to my destination port any later than a fixed moment. So find me the route that consumes the least amount of fuel compatible with me getting there in time. That's a typical problem. But you could also frame other problems like I have a fixed amount of fuel, get me there the earliest possible. Or I want the safest route, or possibly a combination of all this. Okay, so this is up to the customer to define. And once the problem is well defined, then we have a lot of optimization methods. And again, I remember when you did the publicity for this event, I think somebody said that there's this and that, and there's even a mathematician, right? So I'm the mathematician. No, I'm even the mathematician. So I will not bother you with all my mathematical jargon. But anyway, you need a lot of rather advanced math and optimization to actually find what these solutions are. Now, one sector that was mentioned in the earlier talk, and that's actually worth looking at, is what they're called wind-assisted ship propulsion systems, which is nothing else than putting sails into boats. So it took 40 or 50 years to move from sails into carbon, and maybe it will take another 50 years to move back into sails, because there's a lot of people that claim that this is part of the future. Now, there's very few boats with sails. Now there's only around 50 cargo vessels in the world that incorporate sails out of a whole population of 60 or 70,000. Okay, so it's a very, very say starting technology, but we can help these people by simulating the effect of the sails on the route that they want to operate. Okay, so what we do at the end is simulate consumption and finding optimal routes. So summary, I'm not yet done because I have a small demo that I would like to show you, but the summary, we can simulate the fuel consumption for any vessel operating any route under varying weather and ocean conditions in real time and with accurate forecasts. Okay, with our initial calculations and simulations, the route optimization So just telling the captain where he or she should steer the vessel will allow a 2% reduction in fuel consumption, which to you it might say, okay, 2% does not match. That's a lot. Believe me, at the end of the year, we're talking of a huge amount of money that can be saved by just something which is very, very simple. Okay. And finally, where we want to go into is to do performance monitoring and optimization. That's placing sensors in the vessels and actually developing data-driven models that adapt to each particular vessel. Okay, so this is pretty much everything that I wanted to show you. And if you allow me, maybe I still have 3 or 4 minutes to show you a demo. Do I?
Yeah.
Okay, so do you see my screen? Yes, you do now. Okay, so this is the front end of our demo. So here you have all the IMO vessels. Okay, fortunately we have a filter. So let's choose a container ship. So the largest, and let me try to choose one which is big enough. So I'm going to use my filters to maybe not the largest ones, but ones that are more or less on the bit. So this one is good enough. Okay, so we choose this vessel. Here we have all the characteristics from the vessels, or for the naval engineering people. Now I need to choose the route that I want to operate, and we have a number of pre-configured routes. So this one is one that crosses the Atlantic. And then you need to choose, of course, the date in which you want to depart. And this is important because for every single day that you choose, the system will load the ocean and the weather conditions for that day and the forthcoming days. Okay, so let's choose the 2nd of February. So this is, we're simulating something that happened in the past, but there's nothing wrong with that. Okay, and now I optimize the route. And you see, and now what you will see probably in a second is, if this thing loads, you will see all the ocean currents that were in the Atlantic Ocean on the 2nd of February of 2022. Meanwhile, while it loads, let me load the shortest distance route, which is that one there. Do you see the currents now? There's this wiggly thingies. So if I zoom in, probably you will see all this vorticity of the different currents. So it's a complex pattern, as you see, because this is turbulence and it's a chaotic system. But here you have all the currents. So in some places you have a current that helps you move, and the other one, the current is against. Okay, and currents can be up to 2 knots, sometimes even 3 knots, which is 10% of a typical vessel speed. So you really want to take it on the right side. I mean, it's 10% that it's helping you. We also have the wind data. Okay, so this is the wind data. Again, different pattern. Wind is both on land and on the sea, and this is the wave height, which has a big effect in navigation also. Okay, so there's a color code with the wave height, and as you see, when you progress, this is on the 2nd day of the route, the whole weather information is changing. Okay, so here you see that there's a small storm forming a little bit north of near Newfoundland, which actually evolved. So you have all the data. You have very, very good forecasts. Okay, what you see here is all these patterns that the vessel is going to encounter along the route. And if I load here the optimized route, you will see in this particular case, the optimized route is green and goes up here. According to our model and to our calculations, this will save a little bit more than 2% fuel, which converted into money is around $23K. And perhaps what's more important than that, you are avoiding to release 63 tons of carbon dioxide into the atmosphere. Okay, so with something as simple as following a different route from what the straight line route would be. Okay, so the blue line is the straight route, is the geodesic or orthodromic or however you want to call it, and the green one is the optimized one. Okay, and here you see why it's actually saving. You see towards the last 2 days of the route, the shortest route is going through a zone where they have very high waves of 4 or 5 meters, whereas the other one is avoiding it. So if we go to day 7 towards the end of the route, you see this is the This is the storm there with high waves, and you see the blue route is going right through it, but the optimized route is actually more or less avoiding it. So it's crossing an area that has lower waves, and therefore it's a lower resistance. Okay, so just to conclude, let me just wrap up with how I started. I started telling you about a car route where the shortest distance was not the best. And here you can see the summarize of these two examples. So the shortest distance here is 6,744 kilometers long. And it cannot be any shorter than that by definition. Now, the optimized route covers a larger distance, actually almost 60 kilometers more, 55 kilometers more, okay? Nevertheless, it does so in less time, so 3 hours less, and it does so with a smaller consumption, namely 25 tons less fuel. Okay, so it's exactly as in the example with the car that I showed you before. So as a take-home message, there's no reason why you should take the straight route, even if you're traveling on the sea. Okay, and this is more or less what I'm trying to communicate with all this project. I hope that it was properly understood. And if you know anybody that might be interested in collaborating with us, we're very actively seeking collaborators to apply for European funding and to get all these things tried out on the real.
Okay, thank you, David. Very exciting, very interesting. I might just add a quick question. Where do you see the demand for further research?
Well, there's so many things. I mean, communications and placing sensors on the boat. Most of the vessels out there, they are operating with a technology that you would be surprised. I mean, there's essentially human-like people writing things with a pen on a paper, measuring things by, putting your finger up there. So, of course, the new vessels are sensorized, but all the old ones, which are still in operation, and they will be for many years, they're definitely not optimized. Okay, so that's one direction of research, I would say. And the other one is try to integrate all this data, accessing probably the consumption data, which the shipping companies are very reluctant to share. And I don't know why, because there's nothing wrong about that. I mean, if they shared their consumption data, they would all collectively benefit from it if people help them to harness value out of that data. But so far, our hardest obstacle has been trying to get in contact with shipping companies that would give us their consumption data. For some reason, they don't want to do that, and I'm not sure why.
Okay, I don't see any questions.
Sorry.
Yeah, Luca?
Can I ask a question?
Sure.
Can I share my screen just
Absolutely.
for a moment? Yeah. If it's okay with you, with the organizer.
Just a quick question.
Yeah. Sorry. Can you see the screen? So on the right side, you can see the paradox here from the by using linear regression. So this is simple statistics. On the downside, you have distance, and on the other side, you have price. In maritime transfer, we have paradox. By increasing the distance, we are lowering the costs of the transport. This is a paradox, and just something to think about in your project. And on the left side, you can see, let's say, the route originating from Far East to North Europe. When crossing this border, Alexandria in Egypt, if we have, let's say, cargo destinated in the middle Europe, the ships are going through Gibraltar and running towards Rotterdam and Hamburg. This route is 2,000 nautical miles longer than going through the North Adriatic ports. So North Adriatic ports have 7 days in advance to the alternative routes. And this alternative route consumes, let's say, and generates 40 to 50% more environmental damage in sense of emissions than the others. So to answer your question, I think that ship owners won't tell you and won't give you the data on the fuel consumption, but because this is a set of regulatory, economic, politics, and everything else from the external environment, which is integrated in the creation of these cargo flows. Because with the simple analysis of this graph, and on the other hand, if you see here in the road component, you can see the linearity of in the correlation between distance and price. Okay, so just to comment and not to consume any other time. So sorry.
Very interesting. We should definitely talk. We definitely talked about this, but probably outside the talk.
Sorry.
But, thank you.
Yeah. Also, thank you, David. And we have some time for discussion after Nile's talk, but Nile is tight with regard to her schedule, so I would like to give her the floor. Nile Matsluk is an expert and professor for international law, or more specifically, maritime law at Kiel University. And her talk will be on irregular migration via the sea, challenges for the law governing maritime transportation. So it's a very specific and slightly different talk, but still very interesting and timely. Nile, the floor is yours.
Thank you so much, Nicole. I hope you see the right screen, so the big screen and not the two little ones. Even after 3 years of pandemic, it's still challenging to operate a Zoom conference with two different monitors. So thank you for having me. Yes, indeed. My talk goes into a slightly different direction. But I think the challenges for maritime transportation, we will see connections, and certainly, well, the one connecting factor is always the money and insecurity about regulations. Costs a lot of money. I think that could be a common denominator where we all agree. What I will do is to give you a short background, a short introduction to the background in terminology, then talk a bit about search and rescue, particularly these areas of uncertainty that potentially can cost a lot of money, not only in delays, but also in fines and criminal liability. We have a look at access to ports and disembarkation of rescued migrants, and then I will summarize the challenges and hopefully end with some outlook and perspectives for legal certainty for the shipping sector. So having said that, I will focus today on merchant vessels, so on commercial shipping, on transportation, and not on government vessels. I will mention them, but that's a completely different phenomenon. And I will also more or less leave aside the private rescue vessels that are waiting on particularly the Mediterranean for search and rescue incidents. Migration via the sea is not it's not a regional phenomenon. We have so many reasons why people choose to leave their homelands, may that be persecution, oppression, war, terror, hunger, lack of economic opportunities, or environmental change. And very often we don't have one single cause, but we have a mixture of these and other reasons why people try to cross the sea to find better livelihoods on the other side. Today, we very often focus on irregular migration flows, and this is what I will do today, and that basically means movement that takes place outside the regulatory norms of the sending, of the transit, and the receiving country. Mixed migration, and I've mentioned that, refers to those movements where we don't have just one category of migrants, but where we have different groups. So where we have people that are subject to human trafficking, where we have refugees in the proper legal sense, fleeing persecution, and people who would legally not qualify potentially as refugees or asylum seekers, but still are trying to seek better economic opportunities. Very often, refugees and migrants travel along similar routes and by similar means. So human smuggling, again, something we will not focus upon today, but it's also regulated on the seas, plays a significant role here. The basic considerations of search and rescue, and here I would like to draw your attention to potential gray zones. Well, it starts with very easy legal regulation. We have Article 98 of the Law of the Sea Convention, which is really just one example from a variety of treaties and customary law, saying that all states, because public international law works between states, must oblige the masters of vessels flying their flag to render assistance to ships in distress, and that's it. If you come across an incident, you have to rescue, if you can rescue without endangering your own ship or life on board of your vessel. So this duty, this basic humanitarian solidarity duty applies to all vessels, including commercial vessels, government ships, ferries, cruise liners, and so on. And this is, it shouldn't be necessary to mention this, but I still do. The duty to save lives at sea is completely irrespective of the status of the rescued persons or of the potential contribution of that person to the situation they find themselves in. Because sometimes you can read in the media that those people who enter a rubber boat at night on the Libyan coast where we have waves and wind, they contribute to the situation of distress because it's foreseeable that you will not be able to safely cross the sea in a rubber boat. However, if people set out to sea and they come into an emergency situation, even if it was foreseeable or close to certain that this would happen, it doesn't change anything on the duty to rescue. The rescue operation only ends when people are brought to a place of safety, and this is where we enter into some gray zones, because it's not certain where ships can disembark people. So you have to bring them, if you are the master of a commercial vessel, you rescue migrants, you have to bring them to a place of safety. That could be a place on land, that could be another boat, but in any case, it's more than just dry land under their feet, but it's a place where there are some opportunities to continue. And since we don't have a corresponding duty of coastal states to accept persons that are rescued at sea, we have a certain leeway for states, and we have a gray zone and a huge zone of uncertainty for commercial vessels if they comply with the duty and accept people on board. Because what you want to do as a commercial vessel, you want to, as speedily as you can, disembark the people you have rescued. And you would then, in the Mediterranean, but also in other parts of the world, Australia, for example, be faced with a situation where the coastal state closes its ports. And already we can say, well, does a place of safety mean the next port, the closest port, or the next port of call? And there seems to be, in the sense of our economic considerations, the agreement, it should, for merchant vessel, be the next port of call. So you continue your voyage, and if you stop anyways, you disembark the people. But then if the coastal state does not let you enter the port, relying upon that you are not just coming to load or unload cargo, but that you want to disembark people that do not have travel documents, you might be faced with a situation where you have to wait, or where you have to carry on with all the negative economic consideration. So the general rule, states are not obliged to open their ports for foreign vessels. Under the law of the sea, there is a principle of non-discrimination. So if you're a merchant vessel and you're engaging in trade, and a state does open the ports for international trade, there is the presumption of non-discrimination, that it is then open for all vessels. But in this context, where a ship does not come just to trade, to load, unload cargo, but to disembark irregular migrants, this principle doesn't really fit. It might get to the situation where merchant or private rescue vessels, if they cannot disembark the rescued persons, come into a situation where this rescue vessel itself finds itself in a situation of distress. So if you are a merchant vessel, you do not necessarily have the provisions on board to cater. You don't have the sanitary conditions on board for a large number of people. We have just seen the pictures of the huge container ships that can run with a very, very limited crew of maybe 10 people. And if the facilities for these people, for 10 people on board, are suddenly faced with a situation of accepting 50 or 60 rescued people from a sinking migrant ship, you can very quickly come to the limits and capacity of your own provisions, and then be in a situation of distress if you cannot speedily disembark the people on board. However, even if you are in distress because of the rescue mission, there is not an automatic mentioned right to enter a port of refuge in the Law of the Sea Convention. So again, we have a situation of uncertainty. Even a customary right to enter a port in case of an emergency is not absolute. It's debated, and it does not necessarily mean disembarkation of rescued people. It just means that you are assisted. Maybe our medical supplies are brought on ship, water, food, but it's not an automatic disembarkation, and this creates a considerable hardship on merchant vessels. In a nutshell, so that we have time for a short discussion, what are the challenges for marine transportation? Well, each rescue mission leads to potentially high costs for delays for merchant vessels, and in certain cases risks of criminal charges. If you bring irregular migrants and you disembark them, there may be fines, there may be criminal charges of working together with human smugglers. This applies particularly to private rescue vessels, but also merchant vessels. There have been attempts to fine them for a breach of our immigration regulation of the port where they called and tried to disembark. So you have a high risk. It's a potential safety and security risk for merchant vessels to take rescued persons on board. And Magdalena in her very first talk talked about, well, what's the difference between safety and security, and both can apply here. So safety, because if your ship is overloaded, if you don't have enough supplies, it's a safety risk, but it could also be a security risk. And there have been cases where the traumatized group of migrants on board tried to take over the ship. So there's high risk involved, particularly if it's unclear where and when people can be disembarked. These consequences in turn may mean enhanced risk for irregular migrant vessels, because if merchant vessels, contrary to the law, are not coming to rescue. And there have been reports of cruise liners passing by relatively obvious cases of distress, with the allegations that they deliberately chose not to rescue in order not to have to take on board irregular migrants where disembarkation is unclear. This should not be the case, and I'm sure this is not the regular case, but there is an enhanced risk if merchant vessels cannot be sure, or private vessels cannot be sure that they can actually disembark the rescued people. Private rescue vessels, just to mention it here, are faced with significant restrictions. They are challenged with regard to their freedoms of the seas, with under national law, with more and more regulations, barriers, in order to prevent them to do their business on the sea, trying to rescue irregular migrants, because well, they obviously fill a gap that has been left in the Mediterranean in any case when Italy and the EU stopped their rescue missions. We will not go into detail on pushback operations by government vessels, but they do add to the difficulties, and they certainly raise significant human rights issues, and the newspapers, unfortunately, are full of such cases. Well, as an outlook, are there perspectives for legal certainty? No, not really. So the lack of clear regulations clearly leads to difficult situation, and we have an immediate and pressing relevance of the issue, and still we do not see changes or really agreement that addresses these grey zones. Certainly the situation of private rescue vessels add a further layer to the discussion with regard to criminal charges of aiding the smugglers, and the question, well, how far does the freedom of the seas goes? Can I just wait on the high seas for an incident to happen to then rescue, and to have a rescue competition with the Libyan Coast Guard in order to bring people to Europe and not have them pulled back to Libya? So in my view, instead of addressing merchant and private rescue vessels with our obstacles and criminal charges, we need more regional cooperation on search and rescue, and a division of the migrant influx. So including our asylum proceedings, in this case under the EU regulations, but certainly also cooperation in other parts of the world. So a solution must be found across different levels of regulation. So we certainly need dynamic development of the law, but of course we need the underlying political consensus, and this may be much harder to achieve. Often we read, well, we must just address the root causes of irregular migration and then we would be fine. This is a noble aim, but it's impossible. So we see the additional pressure by climate change. As I said, we do not have monocausal reasons for irregular migration, but a mix. And this mix, I'm afraid to say, gets more explosive with wars and aggression and climate change and less economic chances. So we will not see a reduction of irregular migrant flows to Europe and to, for example, Australia, even if we invested more in cooperation with, for example, the African continent, but also other states where we have, like the Middle East, like Afghanistan, where we don't really have a basis for cooperation. So I hope in the short time that we have, I could add to our discussion on maritime transportation, although from a very different angle. And I thank you for your attention.
Thank you, Nele. Yeah, I'm really touched by this. So, but I open the floor for questions, comments. I don't see any from the chat. Luca, was it by mistake?
Sorry, it was a mistake. Sorry, but
Okay.
very, very interesting, very intriguing, and very important.
Thank you.
Thank you.
Yeah, Magdalena.
I had to check where to switch on the microphone. Thank you for this presentation. I found this very interesting because it's somehow also my field of interest. And I would like to ask, do you think there is, from your presentation, I understand there is no solution to that problem so far, but what are the possible paths? Maybe there should be any subsidies from the countries, from the more developed countries to the less developed countries to stop the migration? Or I don't know. What do you think? What are the possible paths to solve this problem?
Thank you, Magdalena. Yes, that's one consideration. I don't think more development or assistance or technical cooperation will stop irregular migration. So I think we will not be able to really address the root causes, but then at least we would need to cooperate to give those who are rescuing security or certainty. So in my view, what's really missing is a clear commitment, a legal obligation by coastal states to accept irregular migrants, so that we do not have the situation that ships are waiting for 3 weeks or more and are sent on to other ports. But this has been tried. And although there are non-binding statements, additions to the Safety of the Life at Sea Convention, to the Search and Rescue Conventions, that the coastal states in the vicinity of the next port of call should consider to take and accept irregular migrants. There is no legal obligation. So in my case, it would be, well, the best way would to fill that gap. But in the European context, I think then one incentive could be that we change the regulations on asylum, because where in a nutshell there, where irregular migrants enter, the state is responsible for all the proceedings. And it has been shown in the past that there has been this bargaining. So the ship is waiting, and then Germany, for example, other states as well, have said, well, we will accept the migrants. Once you let them into Italy or Malta, we will accept them. But only then will we give the commitment. Whereas then Malta has said, oh, you have to give the commitment first, and then we open the ports. And I mean, this is it's like a market. We're talking about people on board who are traumatized and distressed. And I think we need changes in the legal regulations in Europe to divide our migration flows and asylum procedures to prevent that. And on the global level, there should be agreement that ports are opened, that people are disembarked, and then maybe cooperation, maybe subsidies then to assist those states to actually do accept with our asylum proceedings and refugee regulations.
Thank you. There is a question from Leandra from Split, and she refers to the existing observatory for migration in the CEU alliance, and she asks what this observatory could do in the context of our alliance.
I'm sure this observatory, of which I'm not a part, but because I don't have time at the moment, but with which I actually would like to be a part. I think this could. I think this is because it's interdisciplinary and international, could make a contribution. And I know now that from Kiel, Tina Spies, who's our professor for gender and diversity and sociology, is part of that observatory. Before, Zelia Klepp, who has been working in refugee issues and also in search and rescue questions, has been part of it. And I think it can be a very valuable collaborative approach that can influence politics. And in the end, it will be, as I said, we need the political consensus to change the rules and not the other way around. And I think an observatory, like a think tank, and with all the strategies that we have in CEU of science communication, of stakeholder communication, we can indeed make a difference. On the details, I'm unfortunately not familiar with the topics the observatory at the moment is working on.
Okay, thank you. I don't see any questions. Thank you, Nele. So I open the floor for all talks. First of all, I'd like to thank all speakers. And yeah, maybe we have a question regarding the overall topic today. Questions that you didn't ask in the first place, that came to your mind later from the audience, Nele?
It's not a question, it's a comment on the overall format, and I would like to thank you for organizing it. From my perception, but maybe I'm biased because I'm part of the speakers, but I think it worked very well. I would be very happy if we could continue this format with different talks from different perspectives in the future. So thank you all those who contributed to this format, to developing this format. Thank you very much, because I find this very fruitful, and I got a lot of, you need to get ideas even if it's not your particular field. I've learned a lot today, and so I'm very happy about these new Blue Talks.
Thank you, Nele. This is, yeah, this is very valuable because it was the first of its kind in the row, and the next one will be on citizen science in blue economy. It is, Nicola, do you know the date by any chance? Sometime in November. I think it was the 25th of November it is.
Yeah, I think.
In the morning. So 10 o'clock. So yeah. Thank you, Nela. We will try with a few and we'll see and hope. The idea basically is, well, not only to get presentations on very interesting topics, but also to see how this connects, how scientists can connect, and to network among scientists in particular areas of expertise. So
I think that already we have one guaranteed follow-up success between David and Luca.
Yeah.
So
well, this is the obvious, but
yeah,
there may be
good work. So,
there may be hopefully many in the audience that couldn't speak up, but see how they can interlink.
This is the best mapping of our competencies. So I think that this should also feed into future activities, and we should have the notes somewhere of all the potential for collaboration and new projects.
Yeah. Okay. So I think we are done. Thank you to the speakers who took the time to prepare and to present. I hope it was valuable for you too and interesting. And I think I also thank the participants. I think we had more than 28, I think was the maximum number I saw, which I think is really, really good on a topic like this. And yeah, so the next upcoming, I said, is 25th of November, 10 to 12, organized by Cadiz next time. And yeah, so have a nice afternoon and hope to see you at some of our CEU events. Thank you.
Thank you. Bye.
Thank you very much. It was really interesting.
Thank you.
Bye.